So what are the factors that affect the solubility of a solute in a solvent? Well, we are going to discuss two main factors that affect solubility. The first one is pressure. Now, pressure only has to deal with gases dissolved in a liquid. When the pressure decreases, the solubility decreases. If you think about this, you know examples. Those sounds should be very familiar. Whenever you open a carbonated beverage, you are experiencing Henry's law. You are decreasing the pressure exerted on the gas when you open the can. Therefore, the solubility of the gas dissolved in the liquid decreases, and you get the formation of bubbles. So the carbonated beverage is pressurized in the first place to get more of that carbon dioxide gas to dissolve, because that's the part of the beverage that we tend to enjoy. So changing the pressure exerted on a solution only affects gases. The second factor that affects solubility is temperature. And when we talk about a gas dissolved in a liquid or a gas dissolved in a solid, there is an inverse relationship that exists. As the temperature increases, the solubility of that gas actually decreases. The gas will escape. You'll see more bubbles. And then, of course, the opposite is true. You can actually get more gas to dissolve in a liquid at a lower temperature. So let's think about this factor in terms of a 2-liter bottle of soda. If you open up a 2-liter bottle of soda, that's a lot of soda to drink. So if you set it out on the counter and that bottle gets warmer as it comes to room temperature, you're losing CO2 out of the solution as the temperature increases. That's why you want to make sure you put the lid on tightly and put it back in the fridge so that it stays cool and you can keep more of that CO2 dissolved in the soda, so the soda inside the 2-liter bottle doesn't go flat as quickly. I'm going to show you one example of these. A popular candy, Pop Rocks, works on this principle of the gas being less soluble at higher temperatures. So let's try some Pop Rocks. So let's see how well this works here.
Can you hear it bubbling?
I hope you can hear that bubbling. The temperature inside my mouth is much warmer than out here in the environment, so the gas that was dissolved in the Pop Rocks is escaping and giving that bubbly feeling in my mouth. That feels a little funky right now. So as far as temperature affecting solubility, when we try to dissolve one liquid in another liquid, it is a direct relationship. If you increase the temperature of the solution, you can actually get more of the solute to dissolve if you're trying to mix two liquids together. Now, in terms of temperature effects on the solubility of a solute in a solution, the solid dissolving in a liquid is the most common solution that is made, especially in a chemistry lab. So for that, we can refer to this solubility table of different solid solutes dissolved in 100 grams of water. So if you look at this table, you can see for every solid on here that the trend is as the temperature increases, the solubility increases. Now you might say, hey, Schmeck, what about NH3? That's decreasing. Well, good observation. But the reason why NH3 is decreasing is because NH3 is actually a gas. So on this table we have ammonia, which is NH3, and it's actually showing you the trend that you expect for gases. As the temperature increases, the solubility decreases. But let's not worry about ammonia. Let's look at the solids only. So let's look at a few problems that are sure to look familiar maybe when an assessment comes around. Well, first two are just reading the graph. How many grams of sodium nitrate will dissolve in 100 grams of water at 20 degrees Celsius? Well, the graph is a graph of temperature on the x and grams of solute that will dissolve in 100 grams of water. So if we just read the graph, we can answer this question. We got to start by finding the NaNO3 graph, and there it is right there. And now I'm going to look and intersect this graph at 20 degrees Celsius and read the y-axis. So it appears as if about 88 grams of sodium nitrate will dissolve in 100 grams of water to make a saturated solution. So that is the maximum amount of sodium nitrate that will dissolve in 100 grams of water at 20 degrees Celsius. Do the same thing for 60 degrees Celsius. You just read the graph, find where 60 degrees intersects the sodium nitrate and read the y-axis. you get about 125 grams of sodium nitrate will saturate 100 grams of water at 60 degrees Celsius. So you can see that trend. As the temperature increases, the solubility of the solid solute increases as well. Direct relationship. So let's try a little bit harder problem. How many grams of sodium nitrate are required to saturate 150 grams of water? Well, the graph only tells us 100 grams of water. We can just set up a ratio to figure out this problem. If we look at the graph at 10 degrees Celsius and see how many grams of NaNO3 will dissolve, 80 grams will dissolve in 100 grams of water at 10 degrees Celsius. So how many grams would dissolve in 150 grams of water? You can just set up a ratio and then cross multiply and divide. When you do that, you see that we'll get 120 grams of sodium nitrate to dissolve in 150 grams of water at 10 degrees Celsius. The last question asks, if you have 100 grams of water and it's saturated with KCl at 80 degrees Celsius, how much solid will precipitate when the solution is cooled to 45 degrees Celsius? So if it's cooled, the solubility of the solute decreases, so some of it will come out of solution. So we just have to read the amount of solid that will dissolve at these temperatures and then find the difference. So I'm going to look at KCl this time, different graph. I'm going to read the solubility at 80 degrees Celsius, and I can see it's 50 grams of KCl will dissolve at 80 degrees Celsius. And then at 45 degrees Celsius, I can read the graph and see that 40 grams of KCl will dissolve at 45 degrees Celsius. So how much will precipitate if the solution is initially at 80 degrees Celsius and cooled to 45 degrees Celsius? All you got to do is subtract. So you'd have 10 grams of KCl that would precipitate out of solution as the solution cooled. As I mentioned earlier, you can guarantee you're going to have questions like this referring to reading a solubility graph on an assessment.